Hello everyone, I am Praneshwar and I'll be talking to you about data types, variables and literals in Java. First, let's look at a typical line of code that declares a variable in Java. So it would look something like this: int a is equal to 1. Now let's break it down into its constituent components. So first there's int. Int is basically a keyword that expresses the data type of the literal that we're storing in the variable. And what about a? Now a is the identifier. It's very simple. It's just the name that is given to the variable. And then there is 1. 1 is obviously the literal. That's what we're storing in this a, right? Now this may look like gibberish to you right now, but at the end when we go into detail, you'll be able to understand it much more clearly. Here, now let's talk about data types. But before we go into that, what is data? Right? What is data? Data is just some information. It can be your name, which is John. It can be your age, which is 13. It can be the section of your class, which may be A. It may even be your savings or your pocket money, which may be 1350.5. Then we can classify all of this in the English language, right? Types of these information. So John is a word, 13 is a number, A is a letter, and what about 1350.5? It is also a number. And the same way, right, in the English language, it is classified like this: word, number, letter, etc. Java is a strongly typed language. So obviously it will have types for all of these kinds of data. So for John, which is a word, it'll be string in Java. For 13, which is a number, it'll be int, most usually int in Java. If it's A, which is a letter, it'll be char in Java. If it is 1350.5, so here there's a decimal point, so it may either be float or double. Now let's come into more detail. So the data types in Java are broadly classified into primitive data types and reference data types. So primitive data types. What do we understand by the word primitive? It's obviously the most basic form, right? So primitive data types are the basic building blocks of other data types in Java. So a number or a letter, let's take letter for example. A combination of letters make up a word, right? That way. So numbers mainly classified into integral and fractional. Integral stands for integers, natural numbers, whole numbers, and integers. So there's byte, there's short, there's int, there's long, and fractional there's mainly two: double and float. And letter. So letter is a character. Okay, it's expressed by char, and boolean is a binary data type. So it's mainly true or false. It's just true or false, not mainly. So integral data types. When we come to integral data types, these are the four ones: byte, short, int, and long. And all of these, as we can see, are the sizes they occupy. Byte occupies 1 byte, short occupies 2 bytes, int occupies 4 bytes, long occupies 8 bytes. And we can see the range as well. So range in the sense, let's take byte for example, minus 128 to plus 127. Only the numbers within that range can be stored in byte. So you can't even store 128 plus 128 in byte. For example, let's take a water bucket, the capacity of which is just 1 liter. You can't store 2 liters in a 1 liter bucket, right? So now let's look at an example of how it is declared. So as you can see here, dash a is equal to 1. So 1 is obviously an integer, right? It's not a decimal, it's an integer. So any of the integral data types can be used. It can either be int, but int, it occupies 4 bytes, and 1 is, we don't have to occupy 4 bytes to store 1, store the value 1. So we can't use int. I mean, it's not efficient. What about long? I mean, we don't even want to store it in int because it occupies 4 bytes. Long occupies 8 bytes. So, it's very, very, it's not efficient to store a value like 1 long. What about short? Yes, short is occupies lesser memory when compared to int or long, but yet it occupies 2 bytes and we don't need 2 bytes to store 1. So the solution is byte, right? As I said, you can use any of them to store a value like 1, but we should always see the more efficient solution. That's why we are using byte, because byte only occupies 1 byte, which is the minimum amount of memory. So you can visualize a variable like a water bottle and the byte as a kind of thing that allocates the volume of the water bottle, and the literal or one here as the amount of water you're putting inside that water bottle. So, for example, the main reason I'm using my water bottle is for mobility. I want to move it around. I want to take it anywhere I want with me. So if I take a 2 liter water bottle, 2 liter water bottle, and I only want to store like 500 ml in it, is it an efficient solution? I mean, why should I carry a 2 liter water bottle just to store 500 ml of water? Therefore, I will use a 500 ml water bottle to store the same amount, and efficiency is what matters here. Then we come to fractional data types. So fractional data types are mainly numbers with decimals, or rational numbers, you can say. As you can see here, there's float and there's double. So float occupies 4 bytes, double occupies 8 bytes. We'll see why double occupies more memory than compared to float. Obviously, you can see the range here, but there's another reason. So as you can see, a float A is equal to 1.567f. This is the declaration, and double A is equal to 1.567. Then we come to character. So character, there's only one char, which can be used for storing character. So character, I mean, A to Z, or A to Z in the sense A or B or C till Z, or from 1 to 9, or a question mark, a slash, etc. So there can only be a single character. That's why it's called a character, of course. And as you can see here, the range is from 0 to 65535. Now this doesn't mean that you can store numbers in a character, in a character variable. Java uses the Unicode character set, which basically means that each of the number from 0 to 65535 stands for some character. For example, 65 stands for capital A, or yes, 97 stands for small a, like lowercase a. So in that sense, so it's a character set that is used by the programming language, and then we see that it occupies 2 bytes. So now let's look at a declaration of a char variable. As we can see, it's char a is equal to a, which is enclosed in single quotes. So obviously the literal, whenever we are using a character literal, it must be enclosed in single quotes. And then we have boolean. So what is boolean? As I said, boolean is a binary data type. It can only be true or false. So that means that it would occupy a minimum amount of storage. So it only occupies 1 byte, but only 1 bit is used. So 1 byte corresponds to 8 bits, and out of these 8 bits that the boolean data type occupies, only 1 bit is used. But do remember that it does occupy 1 byte. Alright, 1 bit is used, but it totally occupies 1 byte as a whole. And this is how we declare it. Boolean A is equal to true. Now let's come to reference types. Reference types are strings, arrays, and user-defined objects. Now what do we mean by reference types? Just like how a combination of letters makes up a word, right? The same way, a combination or a collection of primitive data types makes up a reference type. So for strings, as an example, a combination of characters makes up a string. As you can see, a string A is equal to hello. And in arrays is a different kind of data type. Like, it's not a specific data type as such. It can be of any type, for example, int, float, double, etc. But this is how it stores a collection of the data type of those certain literals. And then we come to user-defined objects. So what are user-defined objects? They are the data types that the programmer themselves can make in the sense that they can write their own data type. For example, encrypt E is equal to new encrypt. So these are mainly classes, and these are made up of this can be made up of all the data types that we mentioned. So now let's come to variables. What are variables? They're mainly named storage locations in the computer's memory. Alright, named storage location in the computer's memory. So to further understand this, let's imagine the computer's memory to be like a bookshelf. So this is a bookshelf, and there are books in it. Now what are these? What are these books? These are certain values that are being stored in the computer's memory. But I mean, this looks so vague. There's nothing very specific. How can we access any of this? There are no titles on the books, nothing. That's why variables are there. So int a is equal to 1. So let's take that book for example, that green book over there. If we analyze the properties of it, it's of integer type, right? The name is a, so basically you can think that the title of the book is a, and the value is 1. So the book might just have one page on which it is written 1, something like that. Now let's come to certain rules concerning the variables. So a variable can only store a value of a particular data type. What do I mean by that? Let's take the water bottle example. Let's say I have a plastic bottle, and a plastic bottle can obviously only store non-corrosive kind of water kind of substances, right? I guess so, juice or water. But if I pour hot acid, some kind of corrosive hot acid into that plastic bottle, I cannot expect it to not melt. I cannot expect it to store that value because it's obviously going to melt, right? The same way, it can only store a value of a particular data type. So you can just store int a is equal to 1. You can't store int a is equal to 0.1 f or something like that. And then the value of the variable, the name itself is a variable, so it can vary. The value can vary. Therefore, the value can be changed during the execution of the program. So you can imagine this book not as a printed book, but rather as your rough book, on which you've written with pencil, so that during the class or during whenever you want, you can just erase that previous value that you had written and rewrite it. Then we come to literals. So what are literals? Literals are basically just the values that are being stored in a variable. So this is the data that is being stored in a variable, and these fall under the data type category, as we said. So integral data types. Now there are rules concerning different, the literals in different data types. So for integral data types, no decimal point or any other special character must be used. Why? Because it's obviously an integer. An integer won't have any special character except plus or minus. Plus or minus, why? To show whether the variable is or the literal is positive or negative, whether to show the value is positive or negative. And normally, if you've not mentioned it explicitly, if it's plus or minus, it'll just be taken as a positive. And then no single quotes or double quotes, in the sense you can't write int a is equal to double quotes 56, right? Because it cannot be enclosed. It's not a string, it's an integer. It's an integer, yes. So you cannot store it in that way. Although with single quotes, if it's a character, right? When a character is enclosed, like by character I mean, like if it's a, if it's capital or small a that is enclosed in single quotes, it'll be implicitly converted to the Unicode value. So we'll go into detail in that much later, not in this class. But that's called typecasting, typecasting and type conversion. So here it's implicitly being converted. The value of the Unicode value is being taken from the character that we are mentioning. So int a is equal to 2, byte b is equal to 1. So these are kind of the right ways of declaring a integral variable, in the sense these are integral literals basically. And int a is equal to 2.5, byte b is equal to nothing. So what do we see here? 2.5. 2.5 is a floating point or a fractional literal, right? It has a decimal point. It's not an integer. It's a rational number. So it has a decimal point, and obviously that cannot come under integral data type. And byte b is equal to this. So this is actually a declaration error as well. And integral literals cannot be just nothing. So this is a declaration error as well. And integral values, they cannot be just nothing. They cannot be null. So the declaration part here, this cannot be used either with string or char. You can't just write char b or string b or double b is equal to and just leave it blank, right? So that's an error in the declaration. So all of these are wrong. So now we come to fractional literals. So what are fractional literals? They're obviously the rational numbers. So they will have a decimal point. Yes, they will have a decimal point, but you can mention it without a decimal point as well. I'll tell you what I mean. Then with float, as we had already earlier seen, it should have a suffix f whenever it's a float. and then no single quotes or double quotes, and the same thing as int applies here. If it's a character in single quotes, then its Unicode value will be taken. So double A is equal to minus 2.2, float B is equal to 0.f, all of these are right, and double A is equal to 0.5 and float B is equal to 0.5. What is wrong here? So double A is equal to 0.5. Whenever you're mentioning a point, right, there should always be one value, at least be one value after that point as well as before that point. You can't just mention double A is equal to 0.5 or 2 point or something like that. It should either be 0.5 or any number 0.5, and if you're mentioning it as 2 point something, it should be 2.0, 2.1, anything. You can mention it, however, you can mention it as double A is equal to 2 or double float B is equal to 2f. So what happens is, it'll be, when you print it, it'll be shown as 2.0, right? And in the second one, there's obviously the suffix f is missing, so therefore both of these are wrong. Now we come to character. So as we saw, a character is, just one. It can be it can be an alphabet, it can be a number till 9, a single digit number, basically something like that. So the literal must be enclosed in single quotes. In case, so again, here actually, if it's an int, let's say you declare something like int 5, int A is equal to 5, and then you declare char B is equal to A, that won't happen. Then you'll have to do something called typecasting, which will be covered later. But it can be a short or a byte. So a short or a byte. So in the sense, because both of them, they occupy memory that is either equal to or lesser than the memory that is occupied by character. Like byte just occupies one byte. So you can either mention something like character A is equal to 65, and it will still work, but it will not print 65. It'll be taken as a Unicode value, and it'll print the corresponding Unicode character. Alright, so not Unicode character, but the corresponding character to that Unicode value that you've given. So for 65, it'll be a capital A, something like that. But it obviously cannot be a float or an int. In that case, it won't be implicitly converted. And there must be only one value within the single quotes. There must be only a character, basically. So as you can see here, char A is equal to A, and char B is equal to, here it's actually an empty, it's not an empty space, rather it's a space, actually. It's just a space bar. Alright, it's just one click of a space bar. So a space is contained within that, within those single quotes. And this is correct because there's one value, right? But the same thing here in the second one, char B, if you had given two spaces inside the single quotes, it would not work, because there just has to be one character, right? And then we come to char A is equal to double A in single quotes. Yes, that's not going to work. Char B is equal to empty space. Now, not empty space, nothing inside those single quotes. That's also not going to work, because there must be one value inside the single quote. Therefore, this is wrong. Now we come to Boolean. So the literal must not be enclosed in single quotes or double quotes. Must be true or false in lowercase only. So it cannot be in uppercase, because it is a binary data type. Yeah, as we can see, a Boolean A is equal to true, Boolean B is equal to false. So it's very straightforward. This is all there is to Boolean. So it should just be true or false without being enclosed in single quotes or double quotes. And this is right. But when it's Boolean A is equal to T capital or R capital or any of them capital, is obviously not going to work, because it can only be true or false. They're fixed values. And Boolean B is equal to true. Yes, this is string, so it won't go with Boolean. Therefore, it's false. Then we come to a string. So what is a string? It must be enclosed in double quotes. So something like string A is equal to me at 1, string B is equal to null. So null, I'll just come to that in a bit. String A is equal to T, string B is equal to 1. Both of these are wrong, because T is a character. It's only enclosed in single quotes. The same thing, the same T if you are enclosed in double quotes, or the same 1 if you are enclosed in double quotes, it would be right. But here, due to it being enclosed in single quotes, it's wrong. Right, so coming to null, as you can see here, there's no double quotes that are enclosing this null. And that's fine, because null itself is a literal. Alright, so it's a default value of a string when nothing is declared. So it's a literal on its own. So that's about data types, literals, and variables. Thank you everyone for joining. It's my pleasure to have taught